Hello, I'm Woo Kwon and I'm a presenter of this paper on V2X. The outline of this presentation is as follows. First, I will explain about introduction of paper, and I will explain about this DSRC and CV2X, and then compare each system. Next, I will introduce IoV based on big data and IoV based on cloud, and explain the challenge issue.
First of all, V2X mean vehicle to everything, and IoV mean is Internet of Vehicle. In this paper, the author argued that the V2X communication of vehicle is emerging into IoV to support the requirement of developing vehicle service, such as autonomous driving or ITS and advanced driving. And the author argued that it is necessary to learn about V2X before researching IoV. So in this paper, there are three topics about vehicle communication. One is survey of V2X communication evolution, and next is comparison of two main systems of V2X such as 8.2.11 V2X and CV2X. Finally, IoV technology such as big data bases IoV, cloud-driven IoV, and their challenging issues are described. So DSRC means Dedicated Communication. It was adopted in 1999 as an 802.11p based technology. The DSRC consists of two devices. It consists of an OVU that is a vehicle device and an RSU equipment that is a device of base station. So the RSU and OVU communicate with each other and enable vehicle communication. So next is V2X. V2X means cellular V2X, so it is the LTE or NR-based vehicle communication. Therefore, the vehicle and the ENB, which means is E node B, communicates via uplink and downlink, and also side link system. CV2X has a two mode of interface, such as UU interface and PC5 interface. So the UU interface use uplink and downlink to throw the base station, and PC5 interface use the side link system.
The following is a roadmap of DSRC and CV2X and the comparison of each system. The first AO2.11 V2X standard, namely AO2.11p, was published in 1999. The DSRC protocol uses add-on mode and enables direct V2V and V2R communication. DSRC appeared to be a first industrial solution for messaging among the vehicle and roadside infrastructure. However, DSRC cannot always support high data rate due to its limited bandwidth and the low coverage range. So DSRC supports 1500 millisecond delay end-to-end transmission. It can support black warning and application to improving traffic efficiency, but it is not feasible in a high-performance app situation such as remote driving, which need to be fast transmission latency. In 2004, the 2.4 GHz Wi-Fi AFI on ROSA set up the AO2.11b to provide internet access to the vehicle. Wi-Fi is a cost efficiency and show efficiency throughput for UDP and TCP traffic. The outside of the Wi-Fi is the fast mobility of the vehicle. DSRC and Wi-Fi network have a full coverage due to high carrier frequency. This leads to TVWS using an empty TV spectrum to avoid handover and improve the network bandwidth. So IEEE announced the AO2.11 AF standard in 2014 and to share the TVW spectrum. However, TVW spectrum has a problem and ensure the usability of TV band and expensive cost. So Table 2 is the table related to the specification for DSRC and Wi-Fi and TBWS. So next is the CV2X roadmap. As shown in figure 4, the CV2X standardization can be divided three phases. At the first stage, release 14, V2X provide data transfer service primarily for basic and low safety service such as the CAM or BSM or DNN. The release 15 supported advanced V2X scenarios such as vehicle platooning or advanced driving, expansion sensor, and remote driving. Key features include that also is the carrier obligation and QAM or transmit diversity. So and next in the last phase 3, NR V2X SI continue to evolve into enhanced V2X. The following table 3 is comprehensive comparison of LT V2X 55 and AO 2011P. So it means DSRC and CV2X. In conclusion, LT-based V2X, it means CV2X has efficiency advantage over the AO 2011-based V2X. So next is the big data driven IoV. High performance vehicles such as self-driving vehicle are not only consume huge amount of data to obtain vast amounts of information, but also generating data from multiple sensors. Therefore, this paper explains big data driven IoV. Big data enable IoV communication modeling, data assist communication protocol design, and performance evaluation. So next is the challenge issue of big data IoV. First, I will explain the challenge issue related to IoV data sourcing. The data source must be obtained from several entities, such as the vehicle onboard sensor or passenger and road facility. To experientially collect multi-source big data, data source can spread over wide area, so broad propagation coverage and high signal concentration capability must be extended to the application of IoV must be extended. IoV connection must be robust and expansion to gather information and deliver useful message because ITS application require data from large mobile vehicle and load in infrastructure. Since vehicle allow high mobility, IoV supporting to provide timely network access to the transit contact between vehicle and RCU. IoV also require have enough caching spectral buffer the data from randomly occurred event. So second challenging issue is related IoV data transmission. IoV data tasks require different QoS such as different fulfill delay and transmit data rate. The V2X resource management need to respond rapidly to data live and allocate the communication resource efficiently, which is challenging and in vehicle condition. First, the vehicle channel is harsh due to the mobility of vehicle and may suffer from various types of fading, such as the flood fading or shadow fading and multiphase fading. The V2P link can be several interrupted by BROS condition if the relative location of neighbor vehicle change. The spectacular also allocated from the IB is currently not enough to support the high bandwidth transmission. The network topology will be keeping change since the vehicle are moving. So those all the challenging issue about the IoV data transmission. Through the IoV connection, the big data has great potential to further improve the IoV performance by modeling accurate communication process and designing efficient data assist IoV protocol. The IoV transmission can reflect the characteristics of the IoV communication environment, which are determined by many factors that are difficult to observe directly and set up efficiently relationship to the IoV transmission outcome. But by mining massive data transmit via IOB, it is possible to set up the accurate IOB communication model to estimate practical parameter, such as the data arrive or channel characteristic and capacity. IOB characteristics and condition informed by the data. Big data can be used to design efficient data-driven communication protocol. The IOB statistically such as the connectivity of neighbor and transmit buffer occupancy, lifetime of routing path, etc. can be used to predict the traffic load and channel capacity and thought employ adaptive transmission strategies to improving the IOB performance. So next part is cloud-based IOB. CIOB mean is cloud-based IOB. So this paper life cover typically providing a CIOB vehicle service. So first, MAS is the new driving traveling paradigm that does not require a person to own his car. Instead, the person subscribe the mobility service from the MMAS company and can be therefore driving share the car belong to the company. In other words, the customer purchased the mile that he driving instead of car. Second is the remote driving describes the scenario when the driver inside the car cannot driving on his own, exactly to for driving experience when facing complex circumstances. Um, and this time the driver can call the remote driving service cloud and professionally driving sitting in the control center and will take over the control of the car. And also data mining techniques have been widely adopted in a variety of fields, such as online sales, to discover certain pattern with the in-vehicle data collection and reporting to the cloud. And big data analysis of vehicle can also perform in similar manner. So the MEC enhancement CIOB architecture is given in the figure 7. A vehicle may equip the multiple wireless access capabilities, including cellular, DSRC, TWS, unmanned area vehicle, it means UAV, satellite, and they can connect with the vehicle cloud via any available wireless channel. Multi-access maximally guaranteed the connectivity of vehicle for the core cloud, and hybrid cloud architecture is adopted. In this paper, many study of vehicle network are introduced or given this in reference. Although both cloud computing and IoV have been studied for years, CIOB is still facing the many challenging issues. The environment of CIOB comprising not only vehicle and vehicle cloud, but also other related entities such as the traffic managing system, ITS facility, insurance company, aftermarket rotator, and mobility service provider. Therefore, the interoperability among the vehicle cloud, and third-party cloud is the greatly important. Especially, data flowing among the cloud should be trusted and efficient and transparent and immutable. In addition, we need to build the reliability CIB so that people can full embrace the technique without the worry. It should be built based on the following reliability, resiliently, safety, security, privacy criteria. Although the vehicle resource or location have been studied a lot on a specific scenario or target, and there is still the lack of the universal framework to address the problem due to the complexity described above. So recently, the power of AI and the machine learning technique has been demonstrated in the variety of fields. Generally, AI is able to circumvent the complexity under the hood with the half large amount of training data or extensive self-training. Therefore, AI-based methods have been a potential to solve the com complicated virus resource allocation problem in CIV. So the conclusion of this paper is looking back at the V2X development and investigated the roadmap AO 2011 V2X and cellular V2X technique. And finally, we have proposed two important development trend of vehicle communication technology for IoV, such as the CIV, big data driven CIV, and cloud-based IoV. V2X is more so. In conclusion, V2X is more useful than AO 2011 V2X in terms of future V2X, and big data driven IoV and CIV will be also important in the future V2X. So this is the end of my presentation, and thank you.